Section 8.3, example 4, graphing a parabola with a vertex HK and an axis of symmetry parallel to the x-axis. Graph the parabola below, identify and label the vertex, axis of symmetry, focus, and endpoints of the lattice rectum. Right, so y minus 1 squared is equal to negative 16x plus 3. I like it, but I also don't like it at the same time because we have to do a little tiny bit of math right here. It's not in like standard form for us yet. Let's break this up to 4p. Other than that, everything looks really, really good. Really easy for us. We don't have to do not any work, but too much work. So 4 times p, when we factor a 4 out of 16, it gives us a negative 4. So in this case, p is at negative 4. And what do they want from us? They want a vertex. They want an axis of symmetry. They want a focus and the endpoint to make up the lattice rectum. Lattice rectum, sorry. All right, vertex. They want axis of symmetry. They want a focus. And they want the points to make up the lattice rectum. All right, so vertex is going to come from H and K. So remember, H is attached to our X, K is attached to our Y. So opposite of H and opposite of K in this case. X here, so that's going to be a negative 3. Doesn't really look like a negative. Negative 3, much better. And K is attached to our Y, so positive 1. Let's go ahead and start graphing that. If we have to adjust it, we will. I'm going to push this over here. Okay, so starting off with the vertex, negative 3, 1. Already I know that we're going to have to adjust this part. All right, so negative 3, 1, going out 1, 2, 3, and up 1. So we have that. Yeah, we're going to have to adjust this. One moment. Much better. Okay, so from here, vertex negative 3, 1, done. And axis of symmetry. So since this is y squared, it's either going to open up to the left or it's going to open up to the right. Because p is negative, that tells us it's going to open up in the negative direction, so opening up left, which means we have an axis of symmetry coming down this way. So y equals 1, and this is our axis of symmetry. Love it. So y equals 1. Our focus, they didn't mention anything about directrix, so we're still going to include that. All right, focus, we're going out p units in p direction. So negative 4, we're subtracting 4. So going out this way in the x direction. So that would be negative 7, 1. So that's negative 3, 4, 5, 6, and 7. So our focus is going to be here at negative 7, 1. Directrix, we're going out negative p units. So negative 4 or positive 4 from the focus. So 1, 2, 3, and 4. So that is going to be off of here. Directrix, which is x equals 1. And from here, each point on the graph is equidistant to the focus as it is to the closest point on the directrix. So what we say is that we go out, since we are 2p units here, going 2p units out on either side. So from here, p is 4. So we're going to go out 8 units on either side. So going up 1, 2, nope. 1, 2, 3, 4, 5. Okay, let me adjust it and I'll be right back. All right, much better. So going out 8 units from here. So we're going up 1, 2, 3, 4, 5, 6, 7, and 8. So from here off of the focus. So that's the point 9. Actually, no. -7, comma 9. And we're also going to subtract 8 units, which would bring us a -7, comma -7. But just to make sure, we go down 1, 2, 3, 4, 5, 6, 7, and 8. Which is about here-ish. -7, -7. There we go. And start graphing the rest of it. And there we go. So now we are 1, 2p units here, 1, 2p units here, 1, 2p units there as well. I don't think we missed anything, so we call it a day there. If you have any questions, please feel free to ask. Otherwise, bye.